the questions in. Send the question. Send the question. Send in the question. To my phone. To my phone. Send up your question. Physics question. From your home. From your home. Troubleshooting. Physics for real. Oh, you know the thing seal. Alright. So send in your physics questions. Let me do this. I'll let you know the places to send in the questions. Yo, I've seen some interesting messages here, but I can't answer those right now. We are doing some saving of the world. A lot of people asking me, sir, you're doing the physics, sir, you're doing the physics. Well, yeah, we're doing the physics. There we go. Alright, good night, everybody. Good night, George, Shemaine, Ramon, Melanin, K, and Nintendo, George, this new Vanessa, Matthias, Ren, Kalia, and XSS100 gaming. I think this man on my channel since 2018 harassing my soul. I don't know how to block him for this channel. If you hear me, nothing Priya Ramuta. And XSS, be yourself tonight, please. How much time you guys block from this channel? I'll close off the live chat and press like. Alright, here we go. Questions coming in already. Questions coming in already. A lot of them. What's the time? I don't make note of the time. 8 o'clock, right? That way I'll know. I don't want to open the wrong messages here. Some messages are people applying for classes now. Alright, so if you're applying to do physics class, maths class, chem class, whatever class, let's apply after the live now. So the messages don't get mixed up with this. We are about to start. Alright, so a person, now these questions are a lot of writing. So some might just talk. A vibrator on a ripple tank sends waves over the water. The vibrator is now adjusted so that the number of waves created each second is doubled. So you have a vibrator on a ripple tank and it's sending waves across the water by going up and down like that. I always do it. I'll see these things in action. And you adjust it so the number of waves created each second is double. The waves will now have, what do you expect of the waves? To travel half original speed. Maybe I should use the student help to get questions. Nah. Send it to me. Travel at twice the original speed. Have twice the original wavelength. What is wavelength? Lambda? It's been a while. Lambda F wavelength. I've tried the original wavelength. And have half the original wavelength. Pick an answer. Pick a side, there's a war going on. So the handwriting going to be a little rough. Hey, I can get a little smaller here, but too big. That's too small. Hello. 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 Alright. Why am I like this? Let's go. Everybody saying B, have twice the original speed. I don't think so, you know. I don't think so. What gave you that idea? Nah, I know Italian that. I know Italian B training. My answer is have half the original wavelength. You know, because you're cutting the wave faster. It's moving up and down faster, so it creates not faster waves, but it forming shorter waves. in terms of waveforms. So the speed will be the same, as the same amplitude, same energy going out in each wave, so you're going to get the same wave speed. Travel half the original speed. Nah. Where you get these ideas from? Let me double check this. Increasing speed of vibration in ripple tank. Alright, they don't really have any answers waiting for me here. Yeah, the speed of wave depends on the energy in the push, the depth of the push. Increasing the speed of the thing only, just going and cut the wave size. The speed of the wave in the water depends on the depth, so the ripples slow down as this causes the wave length. You really have a solid thing here. I'll you argue over this now. Why this first question had to be a question and 100% sure about? Oh, somebody on my wave here. I'm to join. Yeah, so we have a ripple tank. Everybody press like on the close of the chat, press like on the video. You're increasing the speed of which your ripples are forming. No, increasing the speed of the vibration. That's what the person said. The answer is D. I just know it in my heart and soul, but I like a while solid something to just back me up here. So the vibrator in the ripple tank sends waves over. If you adjust it so that the number of waves created each second is doubled, you're not changing the speed, you're just making it so that it sends out more waves each second. So you're shortening. The speed had to be the same, so the wavelength will shorten. Alright, just believe me on this one. We go ready. Next question. Let me see what else people sending. Shout out to all those who had exams today. How was your exam today? So you have a conductor rotating in a magnetic field. Induces maximum instantaneous current when the conductor cuts the magnetic field lines that all you are reading out some of these things just because you know this writing thing. So a conductor rotating in the magnetic field. So you set up a magnetic field and sometimes you have a coil of the conductor over the magnet, or sometimes be in the solenoid as something. It is an electromagnet here, and sometimes you have the electromagnet spinning one way and the coil spinning the next way. It don't always be like the magnet they show you in the physics book, and you have your one little conductor spinning, so right, it don't always be like that. If you open a motor, open a generator, and them kind of things, you'll see they're a little different. You can check it out on YouTube. So what they're saying is you have this conductor rotating in the uniform magnetic field. It induces maximum instantaneous current when the conductor cuts the field at which is the angle of maximumity. Which is the angle where you have the maximum induction. Talk to me, what is the angle with maximum induction? Everybody can say the answer. CXC spy, what going on? What I'm missing? Why people being so naughty today? Alright. Close off the live chat, press like on the video, open back up the live chat. I have 500 viewers, 295 likes. What I'm saying, you have a conductor rotating in a magnetic field. It induces maximum instantaneous current when the conductor cuts the field lines at what? Answer is C, 90 degrees. Let's move forward with life. Dun, 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 dun. Send your questions in, man. Which of the following distances represents the wavelength of the vibration? So right now they have a kind of meeting going on. So tight, slack, tight. Hey, I run out of space already. What is this? Right. So tight, slack. Let me create my zones. Zion, wake up. Are they sorry about the drawing, yeah? Tight, slack, tight, slack, tight, slack, tight. Right. So it's a longitudinal waves and a slinky. So the slinky tight here, then it's slack here, then it's tight here, then it's slack here, then it's tight here, then it's slack here, then it's tight here. You understand what's going on, right? And A, B, C, D, E. A, B, C, D, E. Who sent this question? Alright, I'll ease up on the questions. We're full. 868. So Trinidad sent this question. Which of the following distances represents the wavelength of the vibration? What letter to what letter? Options are available are A to B, A to E, C to E, and D to E. So which one of these represents the wavelength? A to B? Nah, that ain't really cover the whole thing. A to E? What the? No, there's a lot of waves there, man. C to E? That looking good to me. Like you see D to E? Nah, that's too small. So C to E, start at like, you could actually map out a little kind of transversal something here. It could be like, you went so, and so. Y'all understand what I do there? So like if this is the top, come down, top, come down. So a whole wave is from like C to E. All the rest is like half of a wave. So the whole wave is like from C to E. So C is the answer. Yay. Let's move on. Next question. That's my belly. Right? Look down here with our food, girl. While listening, what's that thing to draw so far? Why? This guy and refers to the following diagram shows palm facing a plane mirror which is 8.5 away from her palm using the image of the vase, which is your how far from palm is the image of the vase. Alright, time to draw. So we have palm. we have palm here. Oh gosh, palm has been drawn. They have a table here. And they have a vase on the table, boy, with a flower. A. This is not art class, y'all. This is physics class. And they have some measurements here for me. I guess palm some here and she head. You have some measurements here for me. So you have 0.5. Guyana, let's come good with this question, boy. You have 0.8, no, 8 meters. Right here, we have a plane mirror. So the question is asking, how far from palm is the image of the vase? How far from palm is the image of the vase? How far? Or however you pronounce that word. So 15.5, 15, 8.5, or 7.5 are the answers that Guyana provided for us. Everyone is saying 7.5. Let's double check. How far from palm is the image of the vase? Well, the way how life is work, Why people saying 7.5? I find that something a little sus. Is the image of the vase? I'll hear in my question, how far from Pam is the image of the vase? The vase. 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 Maybe I don't understand what vase and vase is. So the image will be somewhere here. And that will be the 7.5. But how far from Pam? Because remember, this is a plane mirror, so it has no doubling of length or anything. Magnification is 1. What is called it? No magnification. Images real upright, all them kind of thing. You need to know them thing, you know? So 7.5 here plus the 8 here. So 7.5 and 8 is how much? 8 and 8 is 16, so take away 0.5. D is the actual correct answer. Those was talking other foolishness, cut it out. Alright, that was Guyana. Let me see. Guyana, where you get this? Guyana was sending me questions since long time ago. Here comes Trinidad as well with some whack questions. One is a question with simple harmonic motion, which y'all wouldn't. This is CSEC. This is CSEC physics, y'all. Let me not talk about that. Two aluminum spheres A and B are suspended by insulating threads. If they come to rest as shown in the diagram, the force. What? Alright, two light aluminum spheres A and B are suspended by insulating threads. If they come to rest as shown in the diagram, the force keeping them apart. Is it gravitational? Is it electrostatic? Is it magnetic? Is it centripetal? All those who say electrostatic, y'all are correct. Can be magnetic because it's a sphere too now. It's a sphere, so like having a solid north and south pole and them kind of thing. It's not magnetic. It's not magnetic. Magnetic would be a good answer maybe if you had like blocks not coming together or something like that. Gravitational, them things are real tiny. So, and for them to be kept apart by gravitational force when gravitational force actually pulls things together, so because the gravitational constant is a very tiny number. This is not no gravity to talk about to do any kind of magic tricks like that. Centripetal force acts towards the center, and centripetal force happens when there is like a centripetal velocity or angular velocity. There's no angular velocity, it comes to rest. The question I said comes to rest. So you're not going with C, you're going with B. Why people saying C still? Electrostatic forces. So maybe they was charged up for some reason or the other, and they're like, yo, we do not want to touch each other because you saying things and you saying things. You positively charge, you positively charge. We can just hang out away from each other. Electrostatic forces. So B is the answer there. Trinidad. Let me see what else Trinidad have for you. This is a moderator here. G, F, and L. This is a convex lens, L. At F, if FL is the focal length of the lens and GF is equal to FL. In other words, they're just trying to say this is 2F, right?
Daddy, what sound is that called?
That's an ambulance.
But I'm pretending which sound is it called?
I don't know what you're pretending to be. I'm teaching a class right now. These people are physics somehow.
I told Mommy, yes, I tell what the fan will be. Well, a meal fan.
A meal van or a utility van? Alright. Bye-bye.
Bye-bye.
Hold it up. So GF is equal to FL. And they're asking, where should an object be placed Where should an object be placed? Where should an object be placed so as to produce a virtual and magnified image? And these are the options. At G, left of G, between F and G, or between L and F. Where you're placing an object to produce a virtual magnified image. Chubby, yes, can't win this man in Daddy, what is this? That's a ruler, Chubby. No! No, I'm pretending this is a train track. This man went to really mind and figure out what it is. Daddy, what is this? It's a big ambulance job. It's an ambulance job. No. I'm pretending this is a meal van. So yes, the answer is L and F. If you place it here, you'll get like the same exact image on the next side. But I forget these things. I know for sure if you place it here, it will go backwards. Right? 1, 2. This one goes like this. True. Like this. This one will meet up. The image will be on the other side like that. And you get a magnified virtual image. You can't see that, you can't touch physically. The light rays never reach that image. So it's virtual. The light rays never reach that image, right? So it's virtual. If it's an F, it's the same thing. I'm just touch upon this. I will be going a little hard in physics for the next year. So you'll be seeing the channel. Since I kind of do everything in maths, I'll be going hard in physics next year. So you'll be seeing a lot of physics on the channel. Even for those who do physics for Unit 1, I'll be getting things. They come in at a nice time. Physics is like my first love, but I need to touch upon the memorizing part, theory and things. I'll be teaching a whole lessons class on this. I already have all my physics textbooks in again. I just want to highlight this whole topic here if you want me to know. Yeah, if it's an F is parallel rays. Yeah, I think there's a question too. So for parallel rays, if it's an F, this goes so. That is end up being parallel. And between F and 2F is where you get the real and inverted. Between F and 2F you get the real and inverted. You all know what I'm talking about? Why isn't it chatting? That whole page on your physics book, you need to memorize everything there. And when you memorize it, try and see the patterns. So as it go beyond F, you get a virtual vibe going on. I think I draw the rays a little wrong just now. It goes like this. This goes like this. So they eventually touch and it expands like this. That's what I drew last time? Or I drew it expanding in next week. I think I drew it like expanding like. I think I drew it expanding like that, and I'm supposed to draw it expanding like this. The arrow up here. My diagram in a mess, it's in your textbook. Yeah, eyeball like this. Right. This looking a little better. Why is in the chat if you understand this topic? Read this topic out of 10. That's not my dog, I the neighbor dog. Anytime I start up, he start up too and then he's cool down. So your image will probably be further away than F actually. Read this topic out of 10. You want me to explain through this entire thing, or you're just memorizing this? You need to know this whole entire thing. 7, 3, 2, 4, 5, 9, 6, negative 10, 2, 6. Already going on in the chat, boy. I tell you, what has happened is that you have this long line, you have the lens there, you have F, you have 2F. In this question they call it G, but it's really 2F. You have F, you have 2F, you have that line have a special name, that is the what is called this? What is called this chat? What's the word for that? And what's the word for this line? So if you have something beyond 2F, like something beyond 2F, you're expecting this to go so until it hit there, this to come so, this to go to until it hit there, and you join the two. So use this one, use this one. Have three rays of light you're supposed to know about. The image forms between F and 2F. Let me don't waste time on this. Maybe I should just go through the answers. Maybe I should just go through the answers and the questions. And as I go through it, I just talk about that topic. You all just look at this in your textbook. Everybody should have a textbook. Everybody should have a notes or lessons notes or some kind of thing. And make sure you memorize this whole thing. A little rusty on the memorization of this, but the explanation of it is good. You can always work it back out in the exam using this idea. If a ray pass through and hit here, it will go horizontal. If the ray goes straight here, it will just keep going straight through. And if it go like this, it will come down through F. Not so? Yeah, down through F. But you should know, like, if parallel rays coming from a, you need to know everything in this. A question could come on everything. I just remember that. So just memorize that. Let me see what else they have to offer. Well done, Trinidad. We appreciate your question. Oh Lord, like rays is the whole. What is the SI base unit? Which of the following is a SI base unit? Easy one now. Volts, ohms. I think you're right. Amperes, coulomb. Coulomb. Which of the following is a SI base unit? Everything in physics is a draw. Check out Z notes. Where Z notes is Ariana. Just do questions. Yeah, just do questions. Just do questions. C amperes. Well done. Let me get some radioactivity questions in. I know they are seeing C614. Decays, and when it decays you get this equation. Nitrogen plus X. What is X? Is X a proton? Is it a gamma particle? Is it a beta particle? Or is it an alpha particle? Ariana says it's a site, Z notes. Really? Z notes? What is, I mean, I always patrol in the internet like a watchdog for CSEC. And I didn't know about Z notes yet. Z notes, the ultimate revision notes, with over 20 million. Oh, this is not for CSEC specifically. Alright, you need to log in and in. CSEC physics. I searched for nothing in that. Anyhow, I could check it out, see if you could find stuff useful. She said detailed notes and everything. But remember, you only want stuff that take curriculum. You don't want to be learning one that extra thing. The saying is a beta particle. Let me see. What is a beta particle? An alpha particle is a helium nuclei, meaning 2p, 2 n's. 2p and 2 n's. So alpha particle is helium nuclei. Beta particle is a beta particle. Gamma particle, this is beta particle is an electron. The gamma particle is electromagnetic radiation. Right? So I reaching back into my reaching back in some distant times here to pull out these things. I have all of this pretty fresh after August, so we need some hard revision in physics. So this went from 14 to 14 and this went from 6 to 7. In other words, what really happened here? A proton changed into a neutron. No, a neutron changed into a proton. So a neutron changed into a proton, and when that happened, he decided, take an electron there first. Yeah, that's what it's going there. A neutron changed into a proton. Somebody say gamma is neutron. Gamma is not a neutron, eh? I don't know where you get that from. Beta, you lose one answer. Yeah. So some people saying good things in the chat, some people saying little scary little things in the chat too. So in this case, you had this is 6. And this went to 7. But you notice this mass number, like it remains the same, but the atomic number went up. So it means the proton number went up. So it means out of the blues and neutron changed into a proton. And when neutron changed into a proton, out pops an electron. Look it up. So if it's an electron, it means a beta particle. Yes, gamma is electromagnetic energy, release of electromagnetic energy. EM wave, yes. Nice. Next question. Who sent that one? Trinidad? I don't know. Alright, so more of this. The number of neutrons present in the nuclei of that. Where's Rn? I didn't know it's Rn. Read up. So the number of neutrons present is how much? This is one for the boys. $136, so let's subtract, you get 136, so it's this, take away that, you get 136, right? That kind of easy to see, you didn't need to do no maths, the answer is kind of ridiculous now. So, a radioactive isotope has a half-life of 20 days, is the half-life. How many days will it take for a given sample to have its activity reduced to 1/8? The half-life is 20 days. So how long it will take for something to reach from 1 to 1/8? That's how you need to think of it. 1/8 activity. How many days? And here we have a nice pick of 1.2, 60, 80, 320. How many days it will take for the half-life to reach from 1 to 1/8? These kind of questions come on. Sometimes they draw a graph and how long it will take for the graph to come down to this level. At least, I hope I'm not mixing up Cape physics and CXE physics at the same time here, right? Because it's been a while. I was doing a good at Cape physics recently, but not much CXE physics. Alright, so 1 to 1/8. this is what I need to do. This is what I need to do. Half-life, right? So let me tell you what I would have done in my mind. 1 to a half to a quarter to 1/8. It going down half every 20 days. 20, 20, 20. So the answer is 60 days for the soldier to reach down to 1/8. You understand? Half of 1 is a half. Half of a half is a quarter. Half of a quarter is 1/8. So 60 days, yo. Next question. Well done. So that's some radioactivity. Which of the following diagram best represents the wave generated in a ripple tank by a smooth spherical dipper vibrating at a constant frequency? Ooh, this is a real sweet question, boy. Who sent this question? So you have a dipper, smooth and spherical, and it's dipping at a constant frequency. Dip, 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 dip. So we dip, dip, right? And these are the waves that they have. Now, let me see if I can draw this exactly like how they have it. So this one, what they're trying to show you in this one is that like a uniform. All of them things are supposed to be circles, right? In this one, you have the dipper there, and it close at the beginning, but then it gets spaced out near the ending. And all of them are circles in this one. In this one over here, there's some whack things happening. This one going so. I need to draw this one. Then the wave do so, and then the wave do so. Obviously it's not that, right? That just off. This one I do the opposite thing, so just copy this back. So it's either A or B. So now you say this was A, and this was B, this was C, and this was D. Which one? So a lot of people saying A though. Somebody right, fame kills you, Cohen. Now people are coming for your horn child and your ironic stepdaddy role. I don't know how to read these things. My only other child is, I have no horn children, people. You want to be a kill me? Don't use any time out on hide user. Yeah. Oh gosh, you had to think what you get, yes? So why people saying A? A little suspicious though. Because as the wave carrying out, it moving at that, it dipping constantly, right? I don't know whether for sure whether it's A or whether it will be B now. My instincts telling me it might actually be B, because even though it's dipping constantly, as it's spreading out, since it's spherical, the waves might have to slow down. I'm not too sure. I'm not 100% sure. It could very well be A, right? So let me just double check this to make sure we're moving in the path of righteousness. Dipper, dipping, ripple tank, spherical. I need constant frequency. These ripple tanks, them could be a little tricky, you know. Why is it in textbooks and things I don't know that? This, I need to get my good textbooks and things so I can just grab all these questions. Next year I'll have it down locked. I've never seen this before. Well, thanks. With this spherical thing. What answer are they feeling? Now that they hear me say that. I'll have the answer for you all soon. is A. Is A. Alright. Is A. So the answer is A. A. So the answer is A. Overthinking. Maybe that's why I don't have any knowledge of this kind of setup. So A, if it's moving at a constant velocity, yes, the circles will just be constantly apart. It wouldn't like slow down. Anyhow you take it, it can't be this because they're speeding up. They're saying that the circles further out, speeding up. The only time things speed up in a ripple tank is when it gets shallower. When it gets deeper, it moves slower. And also, alright, it's coming. When it gets shallow, it moves slower, it moves faster. It is A. Yes, I agree it is A. But the next topic in a ripple tank, this is something you need to know. Like if it's getting closer to the beach, the waves is move faster or the waves is move slower. I think it moves slow actually. I say faster just now. So the wave moves slower when it gets shallower, but faster when it's deeper. I'll wait in the chat to verify that for me. So this is correct if it's moving at a constant thing, so everybody answers in this situation. The only time it gets faster is if the water gets deeper. The wave will travel faster. If the water is shallower, the wave had to slow down. Some people are saying faster, some people are saying slower. I am saying slower. The waves gets faster or slower in shallow water. Gets slower. It will travel slower. Slower. Nice. We not get it. Slower. Now you keep moving. You notice why I named the title of this video Troubleshooting Physics. Because I know somebody memorizing thing, I had to go back and check it. From the graph it can be deduced that the runner is okay, so more drawing here. You have 50, you have 100, you have 12, you have 24, WAP, and this is displacement and this is time. From the graph it can be deduced that is the runner going slower and slower? Is the runner going steady speed? Is the runner going, why do you use the word speed though? Faster and faster? Is the runner not moving? Is he not moving? So what's the best answer? Best answer is steady speed. This is a displacement time graph, and constant gradient means constant speed. The gradient is the speed. Gradient is the velocity. So this is steady speed. They use the word speed, but that's the best answer here. Right. Moving along. All those graphs you need to know your displacement time graph, and you need to know your velocity time graph, and all the different nicks and knacks that happen as a result of that. Learn that the diagrams on the scale represent two forces, S and T acting on O, and which of the following is the resultant in the which of the following is the resultant in the direction of OX? Okay, you have two forces acting on an object here. One of them have S doing this kind of semi-demi and T going like this. One of them have S going like this and O going like this. They want it to go in the direction of OS. ST. So this is A, this is B, let's make this C. One of them have S pulling this way and T pulling that way. And would it still go like that? What kind of easy question is this one? One of them have T pulling down and S also pulling down, but somehow they're saying that it will still go in this direction. OX. OX. Which one correct? Obviously A, right? And this question is, I don't know where the exhaust in that question is. Alright, let's keep going. The Rutherford model of the atom suggests that an atom consists of, my physics teacher asked me this in 2003. The Rutherford model of the atom suggests that an atom consists of, is it A solid mass, that's the pi model. You need to know who come up with all the different models, like the Bohr model, the Rutherford model, and the custard pie or something model. Some kind of fancy name. So they talk about it with protons and electrons. So this popular. Thank the Lord I don't have a next life to do after this life. Let's be the worst. Nucleus of protons only with orbiting. So you have protons and you have orbiting electrons. So let me write it out. So the Rutherford model. Nucleus of protons only with orbiting electrons, or nucleus of equal number of protons and electrons with orbiting. So a nucleus of protons and neutrons which are equal number of them with the same orbiting electrons, or a nucleus of protons and neutrons with orbiting electrons. The plum pudding model, right? Who was the plum pudding? The Thompson. So which is the correct answer? Which is the correct answer? Some people saying B, some people saying C. I would go with B because the neutron was not around then in terms of discovery. J.J. Thompson is the plum pudding model. Rutherford is the model with protons only. Positive charge only. He never accounted for the neutrons. So yeah, it's B. Neutrons come in with Bohr. Niels Bohr. Niels Bohr. Is his name Bohr? I just know Bohr. Bohr. Is Niels Bohr, or the I before? The I before E. So Niels Bohr, right? So cool. Good things to know. C and D isn't the same. No, this one is not the same. That is just a little trick to make you try and pick one of these two, but it's none of these two anyhow. Once you see neutrons, then are the Rutherford model. So the Niels Bohr model would be this one, where, because the protons don't necessarily need to be equal to the number of neutrons. It's a kind of ratio that is go up. Is get more neutrons after a while. They start to get more neutrons. Alright, next question. We try and do as many as we can. What time so is a good time to cut off by? The refractive index of transparent medium with a critical angle of C for light traveling from the medium to A. So you're in the medium and you're going to A. And the critical angle is C. So the refractive index is 1 over C. Is it 90 degrees over sine C? Is it sine 90 degrees over sine C? Or is it just sine C? Answers. We get some different answers for this, but we get B, we get A, we get C. I can't remember. You get C mostly now. C is a sine 90. So sine 90 is 1. So 1 over sine C. The critical angle is sine of refractive index is sine of the critical angle. Refractive index is sine of the critical angle. Sine C. If we go in from N class to A, it will be sine I over sine R, angle of incidence at the 90, sine 90 over. That's not. No, angle of. This would be 90, so R. So sine I. So this is the critical angle. The critical angle is the angle of incidence that gives an angle of refraction of 90 degrees. Right. So sine 90. This is from glass to A. So again, sine C on top. But what they ask for, the critical, so it could just be sine C. Just now, what the question asks for? What's the question now? See? From the medium to A, from the medium to A. So this is from the medium to A. From the medium to A. I get in D though. That's not, I'm going to double check this so I can tell you 100% sure. This is correct. From glass to A, sine I over sine R and E. Right, I know this. Then sine I is the critical angle here. And 90 degrees, so sine 90 is 1. So, and you want the refractive index from glass to A. Yeah, sine C. Sine C is N glass to A and it'll be the 1 over A to glass. Answer is D. Answer is D. D people. Sine of 90 is 1, right? That's where we get the 1 from. Now the answer, if they are say from, if the question that just memorize this, if it's going from the medium, we say glass, to air is just sine C. If it's from air to glass, like the normal thing that we know, like the absolute refractive or vacuum to air or air to glass is beyond the same thing, it will be 1 over sine C. This is why I know as the 1 over sine C, not sine 90 over sine C. So my answer, actually my answer going to be just D. So again, real C is the correct answer though. Again, real contention with this one. Now let me read it over again and I'll be able to tell you for sure. The refractive index of the transparent medium with the critical angle C the refractive index of the transparent medium with the critical angle C for light traveling from the medium to air. This question stated I understand why you people can say C now, because here I'm going to write out the question, right? The refractive index, you have to take your time with these questions, but the refractive index of a transparent transparent medium. Now, if you stop right there, the refractive index of a transparent medium, them asking you here for A to G. That's what they're asking you for. The refractive index of a transparent medium, A to G. A to the glass, A to whatever. But then they say now, with the critical angle C for light traveling from the medium to air. So everybody pay attention to how I'm going to narrow down the answer for this. Let me just take off this. I may revert to C. Pay attention to my thinking in this, right? This is more like an English question than anything else. They're asking for the refractive index of the transparent medium for light traveling from medium to air. Now they say medium to air, but that medium to air talking about the critical angle, with the critical angle C for light traveling from the medium to air. Now medium to air not talking about the describing the refractive index, whether you want the refractive index G to A or A to G. So they don't want G to A, they want A to G. So we know this. I just show you how to get out this, right? Using the critical angle that gives the refractive angle 90 degrees, a refractive angle of 90 degrees. Sin I over sin R, you know that formula for index. And you substitute this, you substitute the 90, which is 1. So that's how we end up with sin C is equal to this. And 1 over that is the air to glass. So we end up with this formula here. So actually I would go with the ANG equals sin 90, which is 1 over sin C. So the answer is C. So all people who are holding down the C, I'll get you there. I would stay with the C. I'll go to the C. This part here just means the one refractive index from air to glass, air to the medium. Why is in the chat if you understand that, read that question out of 10 if you feel like you can handle any question that come with refractive index with this kind of formula thing. Or I go on to the next one. If you need me to explain anything over, just say it. Explaining physics is fun for me. Tonight, which of the following arrows correctly indicates the path taken by the dust particle when the switch is closed? Okay. More drawing here. Who sent this? Trinidad, of course. Some people saying this thing, no. Trust me. Stay with C. Like the thing too, when people see me working out stuff, my degree in mechanical engineering, and if I'm working out stuff and I hold it down and I say is C, all you can trust me with the C, you know. Oh, I'll make it look so. Everything I ever do in physics was a distinction. Everything. S. So they have a dust particle here, and they say the dust particle is negatively charged. And they want to know what happens when you close the switch. When you close the switch. Where would it move? Would it move up, down, side to side? A, B, C, or D? Pick one. People saying down. Alright, this is positive, this is negative. So if this is negative, this would be pushed away from this side. This would be attracted to here. Here, I'm going to that. I'm going to be down. Obviously, it's not side to side. Just want to double check something with down. People could be wrong. When it closes, it will go down. This is conventional current here. But how do electrons really move? Electrons move in the opposite direction of conventional current. So the electrons coming down this way. So it'll have a buildup of electrons here. Electrons will be trying to move this way. So maybe I jumped the gun there. Let me just double check that. Conventional current moves from positive to negative. Conventional current moves from positive to negative. Electron flow moves from negative to positive. Conventional current moves from positive to negative. Conventional current moves from positive to negative. Electron flow moves from negative to positive. Alright, yeah. Initial B. Okay, cool. B is the answer. All you can rest assured there. Conventional current moves from positive. That's how they used to think it used to go long time, that is positive charges moving. So it coming on the positive side to the negative side. But the real thing that happening is that coming on the negative side going to the positive side. Alright, so yeah, this is the electron flow here. Yeah, the short side is the negative side, the battery long side is the positive side. So electrons coming this way. So if electrons come in this way, the electrons will be here, so you'll have a repulsion downwards. B is the answer. Alright, so everybody know B. Now you know how to do this question. Any kind of question that come like this, that must seal of approval there. B. the name of the video is Troubleshooting Physics here, so I'll be working all this stuff as I go along. It's not like if I have these answers memorized because I'm doing questions like this whole year. A piece of paper was burned by adjusting the height of a converging lens above the paper until the most concentrated beam of sunlight was obtained. The distance between the lens and the paper was 10. What was the focal length? Oh, this is a kind of way of, so it's a convex lens, and the distance between the lens and the paper. The paper here that burning, the distance, the saying is 10. What is the focal length in centimeters of the lens? And we have options 5, 10, 15, 20. Pick one. So you have a distance 10 from the lens to the paper. What was the focal length in centimeters of the lens? So if it's taking up light from the sun, it means it's coming parallel. Right? That's one of the diagrams that you need to memorize. So if you have parallel rays of light coming through, where it's going to land up? Oh, we have a fight between B and C. I'll tell you just now. Anything going on? Focal, we're going to focus on the focal point itself. So everybody who's saying B, win. So in this case, if you have parallel rays of light coming through, let me just draw the diagram quickly. You have F here, you have F here, and you have parallel rays of light coming in. They're going to bounce up. Memorize this diagram, people. They're going to bounce up. I could kind of shift this lens a little bit so. And shift this a little bit so. And shift this a little bit so. They're going to bounce up right here. So if the paper is actually 10, it means that the focal length itself is 10. Because it getting the rays from the sun. So that's a far distance away, so that means it's parallel rays of light. So the answer is 10. Yes. Next question. That's a nice question. A beam of light passes from one this person, I can't even read the whole question, it cut off. Alright. So we have a next electrical question here. So I think I'm doing the harder questions, right? The questions we're just memorizing, just going and find something in your textbook and memorize it off. Most people can figure out those questions. So this is a question with resistors in parallel. And you need to find the total resistance. So R1, R2, 4 ohms. This one is 6 ohms. And you have a current passing through here of 1.8 amperes. R1 is 6 ohms, R2 is 4 ohms. What is the current through R1 if the current through R2 is 1.8 amps? Is that kind of ratio seen? As recommended. Okay. So you have that there, and your options are 1.2 amps, 1.8 amps, 2.7 amps and 3.0 amps. 1.2, you could watch the answer and figure out is 1.2. This one have a higher resistance, 6 ohms. This one is 4. It wouldn't be more, it would not be the same. So 1.2. In the ratio of 2 to 3, this is in the ratio of 2 to 3. So like it is an inverse relationship now. The less resistance, the more current. But since you see this is 4 and this is 6, this is 1.8. Like this is 18 and this is 12. So this is like 3 6s. This is like 2 6s. This is like 2 here. This is like 3 here. You understand what I'm saying? Yeah. So the more resistance, the less current could pass through. The less resistance, the more current. And anyhow you take it, this was just a quick answer because it wouldn't be the same and it wouldn't be more current. So it had to be nice. Sometimes they could ask you the total current and thing. A conductor. Somebody asked me this already about a conductor and maximum blah 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 blah. Oh gosh, more drawing again. A full-fledged. Real plenty of these lens questions, but let's give people problems. Hopefully the kind of thinking that you see me put on these lens questions, you'd be thinking the same way that I'm thinking and you'll just be able to walk it through in the exam very quickly. So the saying that this is like, what the hell? They do this little weird though. They put 50 here. So it's like a little kind of numbering scene going on here. I'll just make a little more space. 40, 30, 20, blah 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 blah. And 60, 70, 80. Y'all, those who just coming, don't forget to close off the live chat, press like. I seen a little dip in the live. Alia, take some screenshots. Wait, let me draw my full diagram first. Don't take this screenshot yet. Tag me in some posts and let me get some people in for the last run here. Maybe you can make it all the way up to 10 o'clock. 80. Oh, jeez, I need this. I had to go all the way up to 110. And you know now, my diagram not really facilitating 110 right now. So, yeah, what we gonna do? Wait, no screenshot yet. Linking that diagram so. And we're gonna make it up on 70, 80, 90, 100, 110. And we gain something that occurring all the way up there. And this went through 65 and it supposedly hit 30. This diagram in shambles, y'all. So why should we go up a little more? Go up a little more. Right. This went so. And then it hit down so. Alright, then you can take a screenshot now. It's not the best performance this channel has ever offered. Alright, and they want to know in this question, these are not CSEC papers, these are requested questions by students of the Caribbean. They would not send me CSEC papers. This coming down here, I want to erase this a little bit. The meeting, I don't know why I'm spending so much time on this diagram. This chord, ease me up. Right? And they want to know what's the focal length. What's the focal length of the lens? People just answered the question already. 15. 15. Alright, 15. B is 20, C is 60, D is 65. People saying 15 already. Why do they say 15? It's on 30, it's on 2F, and they get that kind of image. Yeah, right. And the giveaway right here, people. Remember this line going parallel and then coming back down? That line always had to come back down and cut through F. So this is 15. So the focal length must be 15. That's the biggest giveaway in this question. So even if you forget that whole page with lens, that whole page with that convex lens, you see 3 questions come under area. That whole page with that convex lens, even if you forget something in it, you could remember, as I said here. You must remember that if something is going parallel, it will cut back through the focal point. If it's going straight through, cutting through the center of the principal axis, center of the axis of the lens, if it cuts straight through, it will keep going straight through. And then it has the next one. If it cuts through the focal length here, like this, the focal length on this side, F on this side, then it'll go parallel here. But my diagram kind of not drawn to scale, so it's not really working out properly. So let me move forward with your life. That's a nice question again. Transformer question now. An ideal transformer has a primary to secondary. So primary to secondary 1:3 ratio. An alternating potential difference of 200 volts is applied to the primary coil. And a resistance of 200 ohms on a secondary coil. What is the current in the secondary circuit? So you have a little ohm, you have some resistance saying down on the secondary. So what is the current in the secondary circuit? A is 0.33 amps, B 1.00 amps, C 1.5 amps, and D what we know with this new boy. Take a little time on your buddy. You are coming off physics class and tell people to press Alt and F4. At the same time, it will take you straight to the student hub. This is a physics class. I think everybody knows what Alt and F4 would do in a physics class. So the 3 amps, let me see why 200, 1 to 3, 1 coil to 3, so you're expecting what? 600 volts. 600 volts. 200 V is equal to IR. 600 volts, 300 ohms, I would be equal to, no, 200 ohms. 200 ohms, right? So I just substitute into the equation on this side. So I secondary, your secondary current will be 600 divided by 200, which is 3 amps. D. That was nice and fun. Well, you're getting to miss out so much of the joys of physics by not getting to do a paper too, you know. Alright, here's the next radioactivity. Sodium 24 decays into magnesium 24 with the emission of a beta particle, and can be represented by the equation. This is similar to what we just do. Anyway, let me not guess the question until I read the question. Which of the following options should be placed in the box to complete the equation? Okay, yes, it's very similar to what we just do. 0E1, which is nothing. There's nothing like that. 0, -1E, C, 4HE1, which is not even an emission. It's supposed to be 2 to be the alpha particle. It's supposed to be 2. The alpha particle is 2, 4 helium nuclei without the He0. I don't even know what the hell this is. So a helium nucleus with no mass. Okay, alright, so it has to be B. So this question, everything here was just ridiculous. This is one for the easy one. So let me try again. You send it. Oops. You send the question right here to that number. Send your questions there if you have any pressing questions. Send the hardest question you have. Preferably nothing to draw. It's styrofoam, igloos, Alright, so you have a styrofoam, you have an ice box. I don't know what it's about this igloo and all kind of thing, right? You have an ice box here. I have some ice in it. That is what Trinidad sent the question I do before was Guyana. And it's styrofoam. In the end of the day, by the evening, all the ice melt. I don't know what kind of ice box is that the ice, all the ice melt by the end of the evening. We just carry an ice box on the beach and all the ice is stay till you're ready to go. In the night, it's still ice inside, they're swimming around. Anyhow, all the ice melt in these people's ice box by the end of the evening. So, why? What's the number one reason? Lost heat. Lost heat through the walls. Okay, now. Lost heat through the walls is one of the things. And the same by radiation. And next one of the things, you all could always go on the student up for some additional work after this. So I'm getting on bad inside anyway. So the other ones are gained heat, which obviously make more sense, right? The ice melting and losing heat. Gain heat through the walls. One is radiation, one is conduction, next one is conduction. Which is the best answer? Gain heat by conduction, one person says. Rata schooler, they buy cheating, that 40, so check WhatsApp. Alright. People only message me on this number. Some of my students have my personal number and just message me there. And I realized that they messaging me some questions there and I only have one number for the exam. I only on this number for these sessions. Most people saying C, some people saying D. Is obviously not A or B, so it's really to choose whether more heat is going to be lost by radiation or conduction. I'm not too sure. See, they indicate styrofoam and they show in your styrofoam and things, so they try to tell you we cover the conduction side of things. That's what they're trying to say. So heat being lost. Yeah, A, B, C, D, right? Obviously. Heat being lost. But still, all of them is A. So, D is a kind of iffy answer, but D is a iffy answer. True is solid, so D. D. Some people saying this question well how people well divided. Now heat will be lost by both. Heat will be gained by both. You would gain heat through the walls by radiation, you'll gain heat through the walls by conduction. But which one is the most? Which one, boy? A cooler gains most heat by what is called it, an ice cooler. Well, I'm not too sure this question. If I was teaching physics whole year, I would be able to tell you one time. I would see it already and vibes it. An ice cooler gains most heat by. Like, the question leading me to say radiation, but like I still feeling conduction in my heart and soul. I wonder what I shade in the exam, boy. I might have shade the conduction. Nah, it had to be radiation, but it had to be radiation. Because like we say, the cooler was on a table or something. That table didn't give in that cooler so much heat, it had to be radiation. And what was the other thing? Convection currents around? Oh, but through the walls. Through the walls. Alright, you read this question, gain heat through the walls. Through the walls. Through the walls is the clue. So what happened when the heat through the walls? How it going through? That through the walls is the answer. It gaining heat through the walls. That is where I'm going with conduction for this. Gain heat through the walls via conduction. So the heat coming on the side of the walls, convection, wherever the air is hot around it. And it will gain heat through the walls via conduction. It have air pockets, right? But it have the styrofoam built around the air pockets. Are you with me now? What you're saying? Styrofoam can conduct heat? Okay. Styrofoam could conduct heat. So these are real troublesome questions, boy. People holding on the answer strong. I feel it will have a physics teacher that will say radiation, and some physics teachers will say conduction. You need to actually do a test on this to see which one will be the most. But my reasoning on this is conduction, because the question is saying through the walls. Gain heat through the walls, not via radiation. I mean, radiation will be happening through the walls as well. But the main vector, the main vehicle for heat transfer will be conduction. What are you feeling with this one, boy? Let me take a vote, or let's say your answer. Which one are you feeling, D or C? This is definitely a question to take to your physics teacher tomorrow morning. Or take that physics teacher that you trust, or take it to the internet and research it. Just to be confident about this kind of question. They say through the walls. Now everybody want to say D now, but people are starting to see my logic something good yet. It's something like it making sense to say the end. We come back to that. I don't want to waste the last bit of this 15 minutes that we have. Our next drawer, and he's saying sorry for making my draw. M, L. So that's one kind of question. Wasn't 200 about N. Item 8 refers to the following diagram. L, M, and N all in the same plane and applied on a ring. Oh, I thought this was on a different plane, and the thing is in the same plane. So all of these are on the same plane and applied on the ring. The ring is R, so I can take out this R. That R is confusing. Why they put that R there for? Which of the following equation must be true in order for the ring to remain stationary? This is bacchanal. So L squared is equal to M squared plus N squared. N squared is equal to L squared plus M squared. N squared is equal to L squared minus M squared. And N squared is equal to L squared, no, L plus M. So which one of the following is true? Which shows three forces of magnitude L, M, and N. Which of the following equation must be true in order for the ring to remain stationary? So I thinking in my mind is that you just do so. You get N here, you get L there, M, L, N. So N squared must be equal to L squared plus M squared. n squared L squared plus m squared, so A, B, C, D. Which answer you all pulling out the hat there? Answer is B. So we want you in Jamaica, okay? But there's COVID around, so I ain't going to fly. Hey, this year I was planning to hit Royal Caribbean countries, no lie. We was done organizing of the tickets and things. I was planning to, right after the exam, you know, finding this country, that country, this country, you know. Go and shake some hands, sign some calculators. But COVID had other plans. So the answer is B. Yes, well done people. Well, Pythagoras theorem. The resultant forces in the dance. This question is vague though, there's some vagueness here. But that's the best answer. That's what I want you to do. In relation to the body waves and neutral, I think most people can. I think you're all sending me the toughest questions. That's why we're getting. That's styrofoam box, boy. That question, boy. So this one is A, this one is B, this one is C. And they're saying this is really easy. I'm not going to go through the whole question. I'm just going to tell you. This is an unstable equilibrium because the center of gravity will fall if you apply a force to it, a resultant force. It might rise and then fall sometimes, but this one will just fall. This one is in stable equilibrium. If you apply a force to it, it will rise and then return back into the original spot. It will tip and then land back down. This one, the center of gravity remains in the same spot right through. If you apply the force, it will just roll. It's in neutral equilibrium. So that's all you need to know. They'll ask you answers about different things here. People don't spam. We have some spamming going on there. Alright now let's spam in our phone. Easy, I know it's last lap. How much people here? 572, we still have 572 going. Pure maths. The price of all my lessons classes are 200 a month, 200 TT a month. If you're paying in another country, it's like 32 US a month when you check the transfer fees. 784, we didn't get a chance to 784 trying to register the classes. I'm just sending the information one time in case I forget. What class is he trying to assign? Maths. Igloo persons 868 send me another question. I know this question like that. That's styrofoam question. I feel it the conduction right now, but the fact that they say styrofoam still lends you a kind of like maybe the person who came up with that question was thinking radiation, but I feel like the true answer would be conduction still. That would be the main vector for, I don't know why. A 50-50, like now I'm starting to feel back radiation again. That question really poses this. The purpose of the bend in these steel pipes, when you have these water pipes and you put a bend in them, and you have like hot air passing through here, steam. What's the purpose of them thing? Let me even put the answers. What's the purpose of the bends? Just write it in the chat while I look at the next question. Everybody should know that. You look at what Guyana has to offer. Nothing to write, something to just read. The glasshouse effect refers to the glass house acting as a heat trap. This is a direction. People still say it is not radiation. Somebody say reduced pressure, that's not true. So don't stream by and come on the same day. Big man, this is not a democracy. I know voting going on here. Expansion is correct. Expansion of the pipes, however. So the bend in the pipes here, when you have a steam pipe and you have a part of bend in it, that's just so that when it expanding it, you know, it wouldn't break. It will expand right here and make a little bend. So most of these things expansion. The glasshouse effect refers to the glasshouse acting as a heat trap. This is a direct result of short wave infrared rays which are unable to penetrate short wavelength infrared rays which are unable to penetrate the glass house. So that is A. Long wavelength infrared waves which are radiated from the sun are unable to penetrate the glass. That just makes no sense. Unable to penetrate the glass. That's B. A is short wavelength infrared rays which are unable to penetrate glass. That goes in the correct direction, but there's still something wrong. Short wavelength infrared rays which are radiating from the objects within the glass house are unable to penetrate the glass. That's the same thing they're saying as A. So short wavelength. They keep saying short wavelength infrared rays. When you're talking about it in relation to everything, is really long wavelength infrared rays which are radiated from the objects within the glass house are unable to penetrate glass. So the answer would be D. The glass house effect, light coming, but the long wavelengths of the infrared waves not getting to leave the glass house. So heat in the place, the back. Alright, now we look at the next question from Guyana again. Why people keep asking me this? Y'all, if you have carbon going to nitrogen, I see this question sent 3 times. Which of the following type of radiation is responsible for this? A proton and neutron changing into a proton because they have the same mass number. Well, what happened here? Emitting a beta particle. So, beta radiation. B is the answer. That's Guyana, Trinidad, X question slowing down like all you expect all the hardest questions. Alright, so I feel like I do all the hardest 3 questions in physics. What should be the magnitude and direction of a third force which will cause the object to remain stationary? So if you want to put a third force, should it be x minus y to the left? Should it be x plus y to the right? Should it be x minus y to the right? Or should it be x plus y to the left? Okay, this one is actually left, this one is actually right, but okay. So x plus y to the left is the answer. Must be D in this case. You must push backwards at it, right? So x plus y to the left. Next question. We have a circuit question again. What are resistor here? You're going to ask me what are resistor now. You have some ammeter there. You have a voltmeter connected in parallel there. What is the resistance? There's actually a question with the voltmeter and they tell you which one of these circuits would work or something, and they put the voltmeter in series or something. What is the resistance of R given that this was 0.4 and the voltmeter is reading 0.6? What is the resistance of R? Well, the tricks in this question, this is a V equal IR question. It's too easy. It's a little suspicious. Alright, so R is equal to V over I. .6 over 0.4 is how much? 1.5? 1.5 ohms. Alright, easy thing, no tricks involved there. Alright, so that's it for questions. Nope, we have some more questions. This was sent already. Like people said that we mean so high. Well done Guyana, that mean make me laugh. No, we have a whole bunch of questions to go again. Let's see how much you can do before. Radioactivity takes place in an atom as a result of what? Is it nuclear instability? Is it nuclear instability, a chemical reaction exposure to heat in excess stress? Nuclear instability is the answer. Radioactivity, don't really care about nothing. You could apply heat, take away heat, do what you want. It's going to be radioactive. Same way, same how, wherever. So nuclear instability. No practical transformer is 100% efficient. Which of the following causes energy loss in a transformer? Which of the following causes energy loss? Is it the resistance in coils? Is it magnetization and demagnetization? I have food waiting there. One hour they get cold and I eat that up. Is it eddy current in core? What causes energy loss? All of the above. Every one of them there causes energy loss in a transformer. You see another question? People asking me to do a CSEC paper. I don't do CSEC papers on this channel. Why? Trying to get me in trouble. Area of light leaves air and enters gas at the refractive index 1.6. It leaves air and enters the glass so it leaves the air and it enters the glass at a refractive index of 1.6 of this is air to glass, and the angle of refraction is 27. What is the sign of the angle of incidence? So the question is asking you, what is sine I? What is sine I? And these are your options. 1.6 plus sine. Still have over 500 people here, boy. Sine that 1.6 over sine 27 degrees. 1.6 sine 27 degrees, or sine 27 degrees over 1.6. Which one? Everybody saying 1.6 times sine 27. Sine I over sine R. Sine I over sine R. Will have to be refractive index, but yeah, this is air to glass. So let me say 1 over the refractive index. So 1 over 1.6. What are you asking? What is sine I? Sine I would be, and R is 27. Why am I getting D though? The refractive index from air to glass is the refractive index. What is it? The refractive index is 1.6. What is the refractive index of glass? Refractive index of glass 1.5, 1.6 thereabouts. This is air to glass. Air to glass. So if it's straight up is air to glass, then it is equal to the refractive index. So yeah. So this is just 1.6 straight up here. So air to glass, refractive index 1.6 of this medium. That's a pretty high refractive index too. So you have sine I over sine R. Sine I in this case is what we're trying to find. So sine I is, and the R here is 27 degrees. So making this the formula 1.6 sine 27. All those who said C and hold on to C even when I was troubleshooting, good job, all you're smart. So C is the answer in this case. We check the next question. No longer wanted to see a question like this. Yo, is that CSEC question? It's in microfarad and thing. This is not CSEC question. 758. Is this a question that can come from CSEC? I mean, I could do it. calculate the steady current through the 2 ohm. Never they'll bring this. That could come for keep people playing games out here, boy. The height of liquid in vessel H. So the height of liquid is H and its density is rho. If the atmospheric pressure is X and the acceleration due to gravity is G, what is the pressure at the base? So what is the pressure here? The acceleration due to gravity is G. So pressure is H rho G, atmospheric pressure is A. So in all, everything is going to be A plus H rho G. You have it like this? Atmospheric pressure is X in this case. X plus H rho G. X plus H rho G is the answer. In this case it was C. Nah, that question that can't come for CXC person. Trust me now. See that for CXC, start pelting your people and throwing their something. You see that question that person sent me. What I was doing and do, I'll open the next question here, but I'm not seeing it now. Answered already. Kind of speeding now, And which of the following diagrams are the resistors P and Q in series with each other? So you want P and Q series and all together parallel at R. So they have some setups. They have P, they have Q, they have R. Why are you writing in this blue marker for? Once you go, you still have over 500, we still going. You have an argument again? This chicken curry argument, boy. Gosh man. So you have P here, this time Q and R. What you wanted, you want P and Q in series and parallel to R. This is P and Q in parallel and series to R. So you want P and Q in series and parallel to R. This one is the correct answer. So C is the correct answer in this case. Let me go forward again. Which of the following changes can be caused by a force acting on a body? Which of the following changes can you change the shape with a force? Can you change the motion with a force? And can you change the density with a force? All of the above. D is the correct answer. You can change everything with a force. You could change the density of a body by applying a force. Depends on the body. So explain this one. Explain this one. Series and parallel with each other. Explain one. So you sure you check C? So explain. I don't understand. P and Q in series. So you have them in series and they parallel to R. Series mean when they come in after each other like this. And parallel mean when it's like this. So if you want P and Q in series to each other and all together parallel to R, what is? Do right like a doctor. So check the back from. A can be correct as well? No. P and Q, this everybody in series in this one. What going on? Wait, no. Yes sir, not at all. It was A for the last one. This one? What are they talking about? This one? P and Q in series and parallel to R. No, everybody in series here. Trust me on this one. I know this real good. C correct. 100%. They have A, I don't care what they have. The question asking for P and Q in series. Where the question is? I lost the question. Let me just make sure the question. In which of the following diagrams are resistors P and Q in series with each other and parallel to R? This looking so, but this is everybody in series with each other. The only way this can be parallel to R is if you have this something linking off like this. Then you have P and Q series and parallel to R, which is this P, but you don't need to pick this because this is clearly P and Q in series and parallel to R. A is also correct. A is not correct. A is not correct unless they put the input and output. But this right now, as it is, it's just a circle. A circle is a Christmas lights. P, Q, R. I feel a little trolling. Don't study what answer sheet they have or anything like that. I tell them the answer is C. Straight up. In which of the following diagrams are the resistors P and Q series with each other and parallel to R? It don't get simpler than that. What's the next question you're doing? This question I would pick D. Let me just make sure. Yeah, I pick D. All of the above. You could change the shape, you could change the motion. Can you change the density of a body by applying a force? I think yes, like you could compress the body, you know. Yeah man, you can change the density. If you're changing the shape, you're changing the affecting the volume, so you end up changing the density. So the answer is all of the above. So force, if you apply a force to a body, depending on what the body is, you could end up changing the shape, making some motion and affecting the density. Sorry for making you draw my first time on the live. Wait, you're the first time on my live after all these lives I've had. What have you been doing in your life? Look at thing to draw. You cannot be serious. In the following diagrams, X and Y. Whoever is this? Unsubscribe. Stop following. Stop it. Come off my channel. In the following diagrams, X and Y represents two wave pulses superposing on each other to give a resultant R. Which diagram best illustrates the principle of superposition? You know what? I'm going to draw everything. So you have this and they are telling me that that is equal to this. That's foolishness. You have this and this, and they are telling me that that's a straight line. That's also foolishness. You have this, and they are telling me that it's equal to the same bump. That is foolishness, though. I go higher. They have this and this imposing on each other, and you get a flat line. That is sense. The answer is D. Blessings, boy. Welcome to the channel. Welcome to the channel. Real series and circuits and things flying in now, boy. Do we want to draw this? You all want to go? Let me ask the question in the chat. You all want to go next 15 minutes? So you can't change density, shape and motion only. Mass can change, not density. This thing get cold here, boy. So right now it's cider and pumpkin. 10 o'clock in the night. The AC was burning and this thing ripping off like paper right now. Yes. I need to eat cold food. That's the help of you. Go on for the next 15 minutes. But we having some argument with the density though. Just shape and motion only. Shape and motion only. It can't be compressed. Shape and motion only. Well, I'm thinking, here what I'm thinking, right? You have a body, right? Alright, but the answer is shape and motion only. If so much people say shape and motion only, there's a trick question, the answer is shape and motion only. But imagine if you have a body and you apply a force state and you compress the body. It reduces volume, but it maintains the same mass. So, it gets more dense. So to me, you could apply force to a body and increase the density. But if you say you're changing shape and you just bending the body but it remaining in the same volume, alright, it didn't change density. But I'm thinking that you can apply a force to a body and change the density. But then again, you need the next force keeping it to squeeze it. You need two forces applying on the body. You can't just apply one force. It can be compressed and it's a body. Then again, you need two forces to compress. You always need a force and the next a resultant force. If you just apply a force, you can change the shape. Yeah, I could understand why the answer could be shape and motion only. So verify. Plenty of people saying shape and motion only. Plenty of people, teachers, tell them shape and motion only. I could stand back and say, alright, shape and motion only. But I hear my argument for density, right? If you end up compressing the body, like if you apply a force and the body get compressed, the actual molecules get closer to each other, you compress the body, you change the density. Alright, but anyhow, let you go forward. And yes, you can compress solids to an extent. Even though for CSEC can't compress solids, they say, but yes, some solids could be compressed to an extent. To an extent. Nothing too big. Negligible. Well, whilst we are looking at some more questions, our next circuit question. So they give us a circuit here. Well, since all you're answering some real way wrong answers for circuits, maybe they might get this one wrong too. You have this circuit here, and you have a light bulb there, and you have a light bulb here. And they say which of these following circuits are the same as this one. So let's see the reference circuit, right? I'm going to draw some more, and they'll tell me which one I'm drawing is the same. And I start to draw it, say that one, say that one. Da. Da da. Dum 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 dum. Da. Dun 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 dun. Alright, so which one of these, A, B, C, D, is equivalent? We're going with motion and shape only. That is a CSEC answer. I can agree with motion and shape only. So we're going to for them kind of questions. C, yes, so they're in series and this one's still in series. More thing to draw again. So this question is saying this, and then it went down. This is from Trinidad. Somebody from Trinidad sent me this question. T1, T2, T3, T4, capital T, V. What the hell is this? Well, we have C written here for. I don't know. That's just a point. So which are the following statements about the object are true? So I guess this is the part of this is the line that of importance here. They just put that in lines there. It returns the starting point. I guess they're asking in that because it went down and went up and come back again. But that is velocity. So no, it did not return the starting point. It has zero acceleration between the times T2 and T3. No acceleration, velocity is constant. That's correct, we're going with that. It has, no, its velocity at T4 is the same as its initial velocity. Initial velocity is here, yeah, so we're taking that. So 2 and 3 is correct, so that answer was C in this case, and 2 and 3 is correct. And I write in all these statements, right? So they just hear these statements, that's it. It didn't return to its starting point, so not the first statement. It didn't return to its starting point. In fact, this just going at a velocity, this going further and further away. Oh Lord Father, this person sent my AC generator. The parts label X. These things in an AC, you all need to know which one is the slip rings and which one is the commutator. So there's always actually that which one is the slip ring and which. If it's a generator, is it a slip ring or a commutator for the generator? If it's a motor, is it a slip ring or a commutator? You need to know that for sure, for sure. We are now 500, it's time to go. Take one jokes as well for you. So the research this thing. Commutators in DC, slip ring, AC generator. Slip ring. It's a whole ring and this thing is slipping around it. Talking it more further. 2 years ago somebody blew me out in my comments. Because I teach in my class on my own YouTube. Back then, I'm like the only man doing this thing here. Live class. How unprofessional this man is eating while the class is going on. This, like, boy, real fight on out here. So if you see a north pole here and a south pole here, you see the whole setup. And a ring thing here, so this going so, and a ring thing here, so, and this going so. What is this? Is that AC generator? Is it a DC generator? Is that voltmeter? Is it a voltmeter or ammeter? Alright, is it an AC generator or a DC generator? Is it an AC generator or a DC generator? Yeah, it's cold, but it's in good still. Body and pumpkin. AC, split ring for DC. Alright, cool, we good. I can't believe this person's an option and this was voltmeter and ammeter. That's just ridiculous. Come on, man. I'm 758. This person said me I can't wait because how far will the car wait to fuel consumption of 5 liters per 100 kilometers go on 15 liters of fuel. You can't get easier than that. I'm not going to bother to do that question. Let's make sure I add this person. Need to add this person one time. Some people already said, but alright people, we leave here. We drop down under 400 and 500. How long will you do this live for? Exactly 2 hours. Really and truly, we need a full 6 hour live to really go through all the possibilities for multiple choice in terms of like what CSEC normally tests on. But I feel it's a good maybe 60% of a wild shot, good 60%, 70%. You'll check the student hub for everything else. I'm seeing lots of questions still. People still asking me about this A, P and Q thing. Yes. people saying that A, P and Q in series. How? How? How this in series? The battery here now. The battery here. The source. The source of energy is here. This is in series. This is in parallel to that. Are you understand what I'm saying? And the one that people want me to pick is this one. Love and blessings are the love and blessings. PQR. This all in series in this. This is what is this? But anyhow, if you have this coming here and this coming here, then that is correct. This is in series and this is in parallel. This is in series and this parallel to that. But other than that, I would go with C as my answer. So thanks for all the help throughout the week. I'm gonna mix a little sugar water, bless up. Sugar water, what are you doing that way? We know that the Lord will continue to bless you all and prosper you all in all these exams, so we're expecting great things tomorrow. Let me get some comments in the chat, so just check back the drawing and see if it draw right. Maybe what I draw, that's the correct thing. The people still put this, so you sure it was the answer. Some people saying A is the answer. A is just three resistors lining in series. You know why I get that A is the answer thing for? Now A can work if it like this, but they did not draw that. They just draw this. As a series boss, I do this thing in university. So it to do any letter and do chemistry, yeah man, blah 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 blah. Alright people, till we meet again, chemistry and bio. I might end up doing both on Sunday because I have a real busy weekend ahead. I may try and get chemistry done Saturday so I can just have bio to do. But by the way, physics, I just know physics in my bones, like physics will be naturally. Chemistry, I understand everything in chemistry, but I forget real things in chemistry and I had to go back and study it. Biology, I don't even teach biology. Biology was just real easy for me and then I never teach it. So a lot of things I just forget. So, but I can't help you in the multiple choice and I'll try to do it live to help the people. We'll see. So don't count on it, that for sure you're coming with bio and chem. Make sure and do your own revision. Maybe chem, but maybe not for bio. Like for bio, I normally have people teaching that for me. If you inform for and you like my style of teaching, you feel, hey, everything this man say I understand, I would be interested to see how this man's conduct a private class. You WhatsApp this message if you plan on doing pure maths or chemistry or even physics in A levels. Keep that number on, save that number, because you'll see a registration thing come out in the middle of August and you'll see what subjects the student hub is offering. I have the free student hub where I have all the resources, all the teachers helping each other. They're helping students there with free questions and one-on-one help, that kind of thing. I have my lessons class, which you could join a weekly ongoing online lessons class for different subjects. I'm trying to offer all the subjects that people request, and the student hub will also be producing resources just like question bank for maths. So there are 3 things the student hub stands for. All the best, amen, and till we link again. Shane, Kristen, Brianna, Taquan, Judd, Terry, Godfall, Alyssa, Okifia, Gabriel, Randy, everybody, 400 of you still here. We outside.